This is for Year 12 Methods. It's the 2014 Functions Application Tech Aloud Section Question 5 Part 1. Sister Mary is very keen for a grand entrance to the new science building. She's asked the architect to provide 3 designs based on appropriate functions. The first is based on a quadratic, and here's the quadratic. It's a from 0 to 2, where a of x is this particular rule, and there's the drawing. How tall is the gate? Looks like 2 meters tall. How wide is it at 1.5 and 1.8 meters? Okay, so I might go over here and enter it. And there it is. I've defined it as being this, and I've put in the restricted domain. So when I drag and drop, it only draws for the restricted domain. So I might change this from 0 to 2. Okay, zoom auto. We'll just draw it exactly as it is, and I'm looking for analysis, G solve maximum, and of course the maximum is 2 meters. How wide is it at 1.5? How wide is it at 1.5 and 1.8 meters off the ground? Analysis, G solve, let's do an X calc when it's 1.5 meters. So the Y value is 1.5, and that tells me that X is 0.5. And if I go across, the other X value should be over here at, so it's going to be 1 meter wide, so I'm going to go from 0.5 to 1.5, which gives me a gap here of 1 meter. And if I do analysis, G solve, X calc, when Y equals 1.8, okay, the X value is 0.66, so I take that and drag and drop it up there. Now I know that the middle is at 1, so keyboard 1 minus that value will give me the distance between there and the middle. So if I take that number and times it by 2, that should give me the width of the gate, which is 0.63 meters wide. A second option, Sister Mary felt that was far too narrow at the top, only 63 centimeters wide. Only one person could fit in and use the gate at one time. So the second option was based on this cubic. But the cubic only shows the left-hand side, and this is the rule where B goes from 0 to 1. Describe 2 transformations that will transform B of x to complete the right-hand side of the gate. Okay, if I take this and I reflect it over the y-axis, it will look like this. Then if I move it 2 units to the right, it will then look like that. So, reflecting over the y-axis, I turn x to negative. Reflecting over, then moving 2 rights to the right, I then replace x. So if I have a rule which says y equals 2 brackets x minus 1 in the middle, and then that is square cubed, and then I plus 2. A reflection over the y-axis, I replace x with minus x. So here I go, I replace x with minus x. Translate 2 units to the right, I replace x with 2 units to the right, therefore x minus 2. So that should be my new rule. Minus 2, x minus 1 cubed plus 2 is acceptable. Or you could write it as 2 bracket 1 minus x close bracket cubed. In here I've taken the negative outside because the negative number cubed is still negative. When the negative came outside to sit here, that negative x became positive x, this 1 became negative 1. So both of these are identically the same. This is what it would look like. This is what it becomes when you clean it up using the algebra. So if I was to graph to double check that I'm actually correct, edit, clear, OK, and I take this graph, I end up with this part of the curve, and that's that bit there. So if I take this and I limit my domain from 1 to 2, and I take all of this, there's the bit that I want drawn, and that's the bit that needs to be added. That's the end of part 1.